Caching is like the process of storing instructions or values into the cache memory. Cache memory is not like RAM, ROM, hard disk drive, or solid state drive. This is basically a storage space, a smaller one, where you store the data of your computer system that has to be frequently accessed again and again. So after they have been used, and if your computer thinks that there is a need that your data has to be used again and again, so they store it into the cache memory. So this basically saves your computer time, which would have been needed to store and retrieve the instructions again from your hard disk drive, which is your secondary storage. So caching is a very common place where you can store your websites, your web page, or data that have to be accessed again and again, so they are cached. So the contents of your website can be loaded again without any delay. So this also means that text and images do not have to be downloaded again multiple times, which is going to free up your network bandwidth as well. A more advanced variation of caching and thinking ahead is prefetching. So, as the word says, prefetching means like in which your algorithm predicts instructions which are likely soon to be fetched. So, instructions and data are likely to be used are then loaded and stored in cache before they are even fetched. So, by thinking ahead, that's how you think ahead, that even before your algorithm is going to implement, it is going to predict how the things are going to be. So by thinking ahead, you are actually spending less time waiting for the instructions to be loaded. Are you getting my point?
Mm. Yeah.
But there are certainly some limitations here as well, and those limitations are like the accuracy of your algorithm used in prefetching cannot always be 100% accurate, because they only provide the prediction, so you just cannot rely on them. And there is also no guarantee on the predictions as well that it will be accurate and right. So the effectiveness of caching also depends on how well a caching algorithm is going to able manage the cache. So larger caches are still going to take a long time to search, and so cache size limits how also much data can be stored. But in general, this form of thinking ahead can be difficult to implement, but it can significantly improve your performance. So a cache is basically a temporary storage where your instructions or data that are likely to be needed are anticipated and stored, and they are ready for fast access. So this this basically replaces the need for recalculation or to transfer the data again and again from your storage devices. So caches like a temporary storage where instructions or data or an algorithm anticipates will be needed as stored. So cache is basically used for websites, access, or contents to be loaded. It free up your bandwidth space as well. And cache is a part of a temporary memory storage where your instructions and data can be stored. And do you have any confusion in this?
No.
Then I have the fourth part, which is the need for a reusable program component. Do you know what is this reusable program component?
Are they like commonly used functions because they can be used again?
Yes, exactly. So a reusable program component is basically an example of commonly used functions that are often packaged into libraries for your reuse. So teams working on large projects that are likely to make use of these certain components in multiple places. It's like you need to use one function on multiple places. So commonly used functions are packaged into libraries. Commonly used functions means commonly used algorithms that are used to complete one task are packaged into libraries for their reuse, so that the same code can be reused at multiple places, and they can put together or they can select which components needs to be reused. But before reusing them, you need to make sure that your algorithm and your code is properly working. So reusability components include implementation of abstract data structures, such as we have queues, we have stacks, we have classes and subroutines. We have just discussed about stacks. So even before you want to re-implement the code of a stack, you need to make sure that that is properly working. And when designing a piece of software, the program should be properly decomposed. It means it's broken down into smaller and smaller tasks. So this basically allow developers and programmers to think ahead about how each task can be solved, and they can actually identify that how the programs and components are going to be developed in the past, or externally sourced components that can be reused to simplify the process. So reusable components are actually more reliable than newly coded components because they have already been tested. They have already dealt with bugs. So it's like, either if you want to create a new code, it's much prefer and it's much better that you use a reusable component, because this is going to save your time. This is going to save your money. This is going to save your resources as well. The subroutines can then be simply reused with the different arguments to produce a variety of outputs. So it's like you can produce well-tested reusable components. That means that they can be reused again and again over your future products that are going to save your cost as well. However, it may not always be possible to integrate existing components, but the third parties with their compatibility issues. But I mean, you need to work with some of the components. So while some of them already exist, but it could be even time consuming as well and more costly as well if you are developing them. But you can use the ready-made softwares if they are actually compatible. So, what are the advantages of the pre-written? The first thing is that they are reliable, bug-free. They have been tested and used many times. They save time for the programmer. They save on development cost of the project, and in some cases, they are also optimized by experts for their efficiency. Like, so we are done with this part as well. Do you have any confusion with this?
No.